Alright, so I got cut off on my last video. I was finishing up number 14. So let me go and show you that one, and then we'll go back and tackle that number 6. So on 14, I think on the last video I ended up with D is equal to 89, and that means this arc is equal to twice that. So 2 times the 89 is how I got 178. Okay, now let's go back to number 6. If I focus on what's going on inside that triangle, I have that case number 1, which is chord times chord, which would be 7 times y equals 6 times x. However, I don't know x and I don't know y. So for the moment, I'm going to ignore those. I'm focusing on this segment and this segment. That's the third case on your formula sheet. We've got 15 squared equals 11, which is the outside part, times this whole entire length. That's 11 plus 6 plus x. That would be x plus 17. We're going to go ahead and distribute and solve for x. $187, subtract from the 225. 38 equals 11x. We end up with x is equal to 3.5 rounded to the nearest tenth. Now I can take that value, substitute it in, and solve for y. We get 7y equals 21. Y is equal to 3. Okay. Moving on to number 15. 15, if you look at your formula sheet, this angle is outside. That means we're going to take 1/2 the difference of the two arcs. One of those arcs is sitting right here at 72. The other arc is here, and they're actually asking me to find that. If you take a look at x, x plus 72 plus the 95 gets me all the way around the circle, which is 360 degrees. So x is equal to 193. Now I've got that larger arc that's an intercepted arc for angle y. Taking 193 minus the 72, I get 121. And dividing that by 2, we end up with 60.5. All right, number 16, I'm looking for angle B. And just trying to see what I can come up with. All right, this is 54. This whole thing is a semicircle, so 180 minus 54 gives me 126 for this arc here. If this is 77, again, if I trace over its side, it corresponds with that arc A. So that means A is equal to 2 times 77, which is 154. Now I've got 54, 126, and 154. Finally, I can go and find that arc up there. And again, I'll show you some work for that. I'm doing 360 minus 54 minus 126 minus 154. And I get 26 degrees for that arc. Now finally, angle B is that first case on your formula sheet. When the angle is inside but not the center, we take 1/2 the sum of the two arcs. So one of its intercepted arcs is here, which is 126. The second arc is up in there, which I just figured out to be 26. And I come up with B is equal to 76. 17. If I trace over angle 80, it corresponds with this whole entire arc here to here, which would have to be twice 80, which is 160. This arc is 40, that leaves me arc D to be 120 degrees. Opposite angles, when they're inscribed in a circle, have to be supplement. So in other words, A plus 75 has to equal 180. We end up with A is 105. The same thing is true. B plus 80 has to equal 180. So B is equal to 100. And finally, I'm looking for C. Well, if you take a look, we've got 110, we have 40, we have 120. So in other words, C has to equal 360 minus the 110 minus the 40 minus the 120. Because again, all the arcs have to add up to 360 degrees. And we end up with 90. Okay, number 18 is the area of a sector. Remember, that is part of the area of a circle. So the part that I want is this degree measure all the way around here. If this piece is 300, that means the rest of it is, if this is 60, that means the rest of it is 300. So 300 over 360, my formula for area is pi r squared. And it said leave it in terms of pi. And we end up with a 30 pi. Number 19, we're looking for the area of the segment. So this is the case where we're going to do the sector area minus the triangle area. So the sector area is that same formula we did up there. We've got 90 out of 360 times our area, which in this case would be 100 pi. That's 25 pi. Formula for area of the circle that we used was that 1/2 BC times the sine of the angle. So 1/2 of 10 times 10 times the sine of 90 gives us 50. And it says take our answer to the nearest tenth. So typing in 25 pi minus 50, we get 28.5. Okay, moving on to question number 20. I know there's one of these on your test as well. How much distance does the wheel of a tire cover if the wheel makes 5 revolutions? So in other words, I want to know how much is this, but 5 of those. That means we have 5 circumferences. That means we've got 5 times 2 pi r. Our radius in this case is 12. That would give me 120 pi. Let's go ahead and take that to a decimal. That gives us 376.9, so that actually rounds to 377.0. Alright, number 20, I ultimately want to find the area. Area formula is pi r squared. Okay, if we're looking for the area, we need to know the radius, and we've been given the circumference. So we've got circumference equals 2 pi r, 225 equals 2 pi r, I'm going to divide by 2 pi. Now when you do this on your calculator, you have to have parentheses around the 2 pi. And we end up with the radius of 35.8 squared and multiplying it by 2 pi. We get 4026.4. Okay, moving on to the next one, we're looking for the perimeter of the hexagon. This is where we've got a tangent from the same external point, means these two segments are the same. If this is 10, this is 10. If this total length is 14, that piece is 10, that leaves this to be 4, this is 4. Again, these segments from the same external point are going to be the same, that's 7. If that total length is 13, that's that's 7, this is 6, which means this is 6. And one hint that I had given you was these lengths should come in pairs. So if you look, these are the same, 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 and same. Finally, I'm going to add those up. And we end up with 54. Okay, the last one. We're looking for the measure of angle ACB. So if I trace over angle ACB, it corresponds with this arc. So we're doing half of 54. BEC, so BEC would correspond with this arc. Notice you have a semicircle, so this arc is 180 minus 52, which is 128. This angle is a central angle, so it's the same. Measure of arc DC, same thing. This is a semicircle, so to find that, we're doing 180 minus 84, we get 96. BCF. B to C to F has this as its corresponding arc, and we figured out that arc was 128, so we're doing half of 128. Gives us 64. And then finally ACD corresponds with this angle here, so it's half of that, and you get 42. Please make sure you do the Excel assignment tonight. You got to get ready for your test tomorrow.